Now that we've talked about all the different rules for naming and all the different kind of steps in the process, we want to put it all together and look at naming as a whole and dealing with describing different compounds. So we have this overall system for naming things where we can start with, is it ionic or covalent? We have our rules for ionic, and then we have our rules for covalent compounds, and we can overall follow those. And so whenever you're naming just something, previously it was name this ionic compound, name this covalent compound, we want to put it together and start by figuring out what it is and then following the individual rule sets. So let's get a bit more practice. What are the names of the following compounds? I got Na2SO4, P2O5, SnCl4, and HBr. I always want to start with, is it ionic or covalent, which really means we're looking for a metal cation or ammonium. If it's covalent, how many in the first element, how many in the second element. If it's ionic, what's the cation, what's the anion. You can use a crossover method to figure out those names. So Na2SO4, Na is a metal. Sodium is a metal, so this is an ionic compound. Okay, so Na is the cation. And so one of the things you'll notice right away, looking at this, so we know Na is the cation, so we could call it sodium. So when we're going through the process of figuring out the name, that means the rest of this has to be the anion. We can see that it is more than one atom. We should start, that should be giving us some alarm bells. This is a polyatomic anion, okay? And so we may not know it yet, but this is kind of the process we can go through to realize, like, hey, I only have, this is an ionic compound. I only have one atom for my cation, so everything else needs to be an anion. I should look up my polyatomics. SO4 is called sulfate, so this compound is sodium sulfate. If we go to the next one, P2O5, P, phosphorus, not a metal. So this is not a metal, meaning that this has to be covalent. So the question is, how many do I have, right? So I take the two P's, 2 right there, and then I take the 5 and 5. And then I convert those just into my prefixes. So the 2 becomes diphosphorus, and the 5 becomes penta for pentoxide. When I look at SnCl4, Sn is a metal. Because that's a metal, that means it's a cation. If you look on the periodic table, Sn is beneath C. It's in the main group over there. It's not in group 1A or 2A. Okay, it's over on the other side of the transition metals. It's in the column beneath carbon. It's number 50. And so it's down there. And so what that means is that it has a variable charge. So in the case of sodium, we knew sodium was in group 1A, we could just call it sodium. But with tin, Sn, it's variable charge, and we need to figure out what Roman numeral we would put there. And we can figure it out based off the charge of the chloride. Chloride is in column 7A. It's a halogen, which means when it forms an anion, it goes to -1. We have 4 of those chlorides in this compound. And so in order to be neutral, I have -1 times 4, right? So that means there's a total of 4 negative charges. The tin has to balance that out and be +4. So this is tin 4 chloride. This process of coming up with Roman numerals can be tricky. But one of the things that we can kind of see in this example is that in the case of, say, the covalent compounds up here, the diphosphorus pentoxide, the 2 on the phosphorus went directly to the prefix on the phosphorus. 2 became diphosphorus. But you'll notice with the tin, the 4 is the chlorines, the 4 chlorides, but that's really reflective of the 4 that is on the tin. It's not always perfect. It's not because if you have, say, an anion that's not a -1 charge, it's not going to be the exact number. But the Roman numeral that goes with the metal is based on the subscript, or determined by the subscript that's on the anion, on the non-metal, in this case the 4 on the chlorine. HBr, H is a non-metal. It's over in that first column, but it is the exception over there. It's a non-metal. So this is 1H and 1Br. No prefixes required. Hydrogen bromide. So naming compounds is in working through the system. The best way to go about this is going to be practice. The best way to get better about this is practicing and practicing and practicing some more. So there's on the homework, there's additional problems on Blackboard about naming. They're just activities and exercises I've used in previous and other throughout my teaching. And so you can take a look at those with answers. There's online resources you can use to get additional practice. And it's really just going to be a matter of working through this. I would start with sapling because that's going to be part of your grade. So I definitely encourage you to take a look at that and the participations, these problems, taking these seriously. But I encourage you, more and more practice is the best way to improve here. Participation 6.5, question 5. What are the names of the following compounds? A, OF2, B, AgCl, C, NH4NO3, and D, TiO2. This is the 5th question on participation 6.5, due Friday, June 5th at 11:59 p.m. over on Blackboard. Link to the assignment is right below the links to these videos. Again, what are the names of the following compounds? OF2, AgCl, NH4NO3, and TiO2. So far we've focused on just taking formulas and coming up with names, but we also want to be able to go the other way. And so this is in some ways trickier, but in some ways hopefully a little bit easier, because one of the purposes of systematic naming is that we want to focus in on having explicit rules. So ideally these names contain all the information that is required to produce the formula. That's the whole point of how we've come up with systematic naming rules. So we want the molecular formulas for dinitrogen tetrahydride, barium sulfate, copper 2 hydroxide, bromine fluoride. So when I'm starting this process, I'm always going to start, the same idea of that when we go from formula to name of is it ionic or covalent, right? How do I interpret this systematic name? If it's covalent, how many of each of them? If it's ionic, what are the cation? What's the anion? Use crossover method, those ideas. And so we really can use these ideas, ionic or covalent, but we can also, of looking for metal cations, but we can also parse other information that's in the name. So dinitrogen tetrahydride. So nitrogen is a non-metal, and it's not the word ammonium doesn't show up. This is just nitrogen by itself. That means this is covalent. The other thing I can see is that there are prefixes in this name, di and tetra. Right away, that means this is covalent. Even if I don't know that nitrogen is a non-metal, if the name has prefixes in it, it has to be a covalent compound. Similarly, we use those prefixes explicitly when we're interpreting a covalent compound. So dinitrogen, that would be 2 nitrogens. Tetrahydride, that's 4 hydrogens. We're interpreting out those prefixes. Di is 2, tetra is 4. So that means this is just N2O4. We maintain the same order with nitrogen being first and hydrogen being second. Barium sulfate. Again, we kind of have some clues that we can use metal cations or whatnot, but the other thing we can key in on right away is that I have this prefix ATE. ATE, as that ending prefix, means this has to be an ionic compound and This is a polyatomic ion. Okay. When we have monoatomic ions, right, sulfide, chloride, those end in IDE. When we have covalent compounds, they always end in IDE. If I have ATE, it has to be ionic. Barium is a metal, so this is an ionic compound, but I can already kind of key in on looking for those clues. When I see ATE, it's ionic. I want to be looking up barium, figuring out what its charge is. I'm not given any information. There's no Roman numerals after barium here. So that means I have to use the periodic table to figure out the charge on barium. It's in column 2A, so it's Ba2+. Sulfate just is SO4 2-. That is the definition of sulfate. We can use the crossover method. We can simplify. We get BaSO4. If we want to look at copper 2 hydroxide, there's a couple things we can key in on. Roman numerals, right away, this is ionic. If there's a Roman numeral in the name, this has to be ionic. Copper is the metal. It may be one you're familiar with. Or you're probably familiar. You've used copper, seen copper. So that's good. But whenever you see a Roman numeral, right away, that's going to be an ionic compound. And you know that the charge on the copper is 2+. Right? You can't use the periodic table. You're just being told. In the case of barium, you had to figure out the charge based on the periodic table. But this, you don't need to. It's copper 2+. It's given to you right there. When we now look at hydroxide over here, it is ending in IDE, which means it's the anion. And so one of the ways hydroxide is a polyatomic, one of the ways you could figure that out through brute force at least, is that hydrox is not the root of any element on the periodic table. There's no like hydroxine or hydroxer, hydroxygen, anything like that. It is hydroxide. So there is no corresponding root that would correspond to an element. This is a polyatomic. It is oxygen and hydrogen together in a polyatomic ion. So you can look that up. It's OH-. But again, you have to know that it's something you can look up. And so hydroxide is going to be one. It doesn't have an ATE that kind of flashes it out. But hydroxide is a very common polyatomic that we'll see. So copper 2 means you have the 2+ charge. Very nice. And then hydroxide, it has a -1 charge. So we can do the crossover method. We do need parentheses in this case because we have 2 around the polyatomic, 2 of the polyatomics. Throw those parentheses on there, CuOH2. Finally, bromine fluoride. So bromine fluoride here. When we're looking at this one, there are no tricks or things to look at. There's no prefix, there's no ATE, there's no Roman numeral, but we have to just go through the brute force. Bromine, not a metal, so it has to be, it's not a cation. Bromine's a nonmetal, fluorine's a nonmetal, so this has to be covalent. No prefixes means there's one of each, so 1 bromine, 1 fluorine. Formula is just BRF. We didn't use monos because bromine would never have a mono and fluorine isn't oxygen, so it doesn't need a mono as well. And again, we have the learning goals for chapter 2. So these are the kind of things you want to be able to do, the ideas, the skills that you hopefully can accomplish or demonstrate now that we're done with chapter 2. So everything back in discussion starts with just the discussion of what atoms are and those ideas, and then that kind of flows in through kind of atomic properties, naming things, ions, and then making the compounds out of ions and naming compounds, all that kind of stuff. A lot of good, the basic kind of language of chemistry. So you can use this if you're looking to prepare for tests moving forward. These are the kind of skills you want to have, or that I'm going to be looking for on those tests. Okay, 5 questions on participation 6.5. You want to find all 5 of them, get them answered, get those answers submitted over on Blackboard by Friday night. Otherwise, this is the last video for the week. There will be the answers for the participation that go live Friday night. Otherwise, nothing else for me.
Module 2 homework due Saturday, covering all this Chapter 2 material. Post-lab for water purification also due Saturday. If you have any questions about anything, let me know. Otherwise, congrats on finishing your first week of material. It's a fifth of the way through the class. If it feels like a lot, it's because it is. If you have any questions or anything, let me know. Otherwise, take it easy. Bye-bye.